Question number 41. If a line AB of length R moves such that A and B always lie respectively on x-axis and y is equal to 6x, then the locus of the midpoint of AB is. First of all, you have here is A and you have B over here. A is given by, you are given that A lies on the x-axis, therefore the point AB can be considered as A comma 0. And B can be considered as, since it's lying on the line y is equal to 6x, that this can be considered as C and 6C. So B is given by C, 6C, and A is given by A comma 0. So here is the line AB and you have the midpoint here C, right? Now let the coordinates of C be H comma K. These are the lines. So you are given that y is equal to 6x for this point B. This lies on this line, and AB is equal to R. One thing more is given to you. Now C is the midpoint. That means it's dividing in AB in the ratio 1:1. A is A0. B point is C, 6C, and C point is H comma K. Now, H can be given by A plus C upon 2. And K is equal to 0 plus 6C upon 2. Let this be equal to K. So you can say C is equal to K upon 3. That means 2H is equal to over here. 2H is equal to A plus K upon 3. Or A is equal to 2H minus K upon 3. Also, you are given that AB is equal to R. That means AB square is equal to R square. That is equal to A minus C square plus 6C square is equal to R square. So let's fill in the values. You had A as 2H minus K upon 3 minus K upon 3 whole square plus 6K upon 3 whole square is equal to R square. This will give you 2H minus 2K upon 3 square plus 36K square upon, okay, this can be written as 9. Wait. They will cancel out and you will write down 4K square is equal to R square. So I'll take 4 common from here as well, and you will be left with H minus K upon 3 square plus 4K square is equal to R square. This will give me H minus K upon 3 square plus K square is equal to R upon 2 whole square. Therefore, the locus of HK is given by x minus y upon 3 square plus y square is equal to R square by 4. Let's check what we have in the answer. Here we have option C. Option C is the answer to our problem. Clear? Hope you're clear with this, students. If you have any doubt, then you can rewind the video and watch at your own pace. Also, do visit our website www.examsnet.com. There you will find a number of entrance exam question papers, so you can practice them at your own time. Also, you can download our app. The link is available in the description box. Let's go forward. Question number 42. All points inside the triangle with these vertices must necessarily satisfy which of these following in equations. So you are given that A is 1, 3, B is 5, 0, C is -1, 2. For point A, 1, 3, 3x plus 2y is equal to 3 plus 6 is equal to 9. That is greater than 0. for point B, which is at 5, 0. This equation 3x plus 2y, I'm considering that only. 3x plus 2y will be equal to 3 into 5, that is equal to 15, plus 0, that is equal to 15, which is greater than 0. Now for point C, that is minus 1, 2, 3x plus 2y is given by minus 3 plus 4, which is equal to 1, again greater than 0. So this equation is satisfying for all the 3 points. Similarly, that means this is most probably our answer, but we'll still check for option A. If I'm checking for option A for point 1, 3, this will give me 2 plus 6 is less than equal to 0. This is not true. So option A is wrong. If I'm going for this one, then this becomes 2 into 1, 2, minus 3 into 3, minus 12. This is greater than 0. No, this is not greater than 0. This is less than 0 because answer will be negative. So this is even wrong. Next, 2 into 1, that is 2 plus 3 minus 13. This is greater than 0. No, this is again a negative number. So option A, C, D are wrong. Only B is the correct one. This is the answer to our problem. Right? Next, question number 43. The line on which the lines this and this with A and not B not equal to 0 intersect for any real values of A and B is. So in this question, we are given 2 lines. That is, let's write down the lines first. AX plus BY is equal to 1. BX plus AY is equal to 1. Now multiplying, let this be equation 1 and this be equation 2. Multiplying equation 1 by B and equation 2 by A. Then adding them. So you will get, this will be ABX plus B square Y minus A. I'll be subtracting both these equations. Okay. So yeah, this will be minus ABX minus A square Y is equal to B minus A, which will on solving will give you Y is equal to B minus A upon B square minus A square, which will be equal to 1 upon A plus B. Now let's put this Y is equal to A plus B in the equation number 1. Y is equal to 1 upon A plus B. Let's put this thing in equation number 1. So you will have it here as AX is equal to 1 minus B upon A plus B. This will give you A upon A plus B. So you will have the X value as A upon A plus B. So their point of intersection will be point of intersection of both lines are of type 1 upon A plus B upon comma. Wait, sorry, here is AX, right? So this has got to be 1. This was AX, right? So here will be 1 upon A plus B. Therefore, such points lie on X is equal to Y line only. Let's check what we have. We have option D as the correct answer. Hope you're clear. Let's move to the next question. Question number 44. For X and Y satisfying this equation, which of the following is correct? So let's solve this equation. Here again, mod of X plus mod of Y is equal to mod of X minus 3 plus mod of Y minus 2. We have 2 cases over here. First is when X lies between 0 and 3. So when X is greater than equal to 0 and less than 3, and Y is greater than equal to 0 and less than 2. So mod of X plus mod of Y, this is, let's write the equation, right? Here's Y minus 2. So this can be written as X plus Y is equal to minus X plus minus 3 minus Y minus 2 x plus y is equal to minus x plus 3 minus y plus 2. Over here, this will become 2x plus 2y is equal to 5, or x plus y is equal to 5 by 2. First thing. Second case, when x is greater than equal to 3 and y is greater than equal to 2. So x plus y is equal to x minus 3 plus y minus 2. This equation becomes x plus y is equal to x minus 3 plus y minus 2, which gives you x is equal to, no, this is actually you are having, this will cancel out, and x will cancel with this and y will cancel, and you will have 0 is equal to minus 5. So this is wrong, right? This is not correct. Therefore, we have this one as our answer. This falls in option B. So this is our correct answer, right? Clear? Next is question number 45. For A, B, H greater than 0, if the slope of one of the lines represented by this given equation is twice that of the other, then the value of H upon A, B is. You are given the lines are A square x square plus 2H xy plus B square y square is equal to 0. Now, let M and 2M be the slopes of the line. Slopes of the lines, then M plus 2M will be given by minus 2H upon B square. Also, let's solve it further. 3M will be equal to minus 2H upon B square, or M will be equal to minus 2 by 3H upon B square. Also, the product of the slopes, that is M into 2M, will be A square upon B square, or 2M square will be A square upon B square. M we just solved, right? M is equal to minus 2H upon 3B square. So minus 2H upon 3B square whole square is equal to A square upon B square, which gives you minus 8H square upon 9B raised to power 4 is equal to A square upon B square, or H square upon A square B square is equal to 9 by 8, which gives you H upon AB is equal to 3 upon 2 root 2. Let's rationalize the denominator. So you will get 3 root 2 upon 4, right? That's, I think we got our answer. You wanted to find out H upon B. The value of H upon B is given by, this is equal to 3, 2 root upon 2. Let's see it. Yes. We have option A as the answer to our problem. Right? Yeah. Next is question number 46. Suppose A and B are the points on the line x plus y minus lambda is equal to 0. Meets the pair of straight lines. This is equal to 0. If angle AOB is 90 degree, then you have to find out the value of lambda. What you are given in the question is the equation. Let's write down the equation first. It is x plus y minus lambda is equal to 0, which gives you x plus y is equal to lambda, or you can say x plus y upon lambda is equal to 1. And the pair of the straight lines is given by x square plus y square minus 2x minus 4y plus 2 is equal to 0. We will make homogeneous of the above line. So making homogeneous, you will get the line equation as x square plus y square minus 2x into 1 minus 4y into 1 plus 2, 1 square is equal to 0. X square plus y square minus 2x into x plus y upon lambda, because I have to introduce lambda in it, minus 4yx plus y upon lambda plus 2 into x plus y upon lambda whole square is equal to 0. So Solving it further from equation 1, I have filled in this thing. Hope this is clear how I've done this. So now let's take the LCM. Lambda square x square plus y square minus 2x square lambda minus 2yx or xy lambda minus 4xy lambda minus 4y square lambda plus 2 into x square plus y square plus 2xy is equal to 0. This makes it lambda square minus 2 lambda plus 2 into x square plus 4xy minus 6xy lambda into lambda square minus 4 lambda plus 2 whole y square is equal to 0. Sorry, here is a plus, not a multiplication. So now let's solve it further. You will have lambda square minus 2 lambda plus 2 into x square. I'll take common from here. That is, I can take xy common from here. So this will become 4 minus 6 lambda xy plus lambda square minus 4 lambda plus 2y square is equal to 0. Now angle AOB is 90 degree. It's given to us. Here, O is origin. So condition for angle ADB is equal to 90 degree is given by coefficient of x square plus coefficient of y square is equal to 0. What is the coefficient of x square? It is equal to lambda square minus 2 lambda plus 2 plus lambda square minus 4 lambda plus 2. This is equal to 0. So solving, you will get 2 lambda square minus 6 lambda plus 4 is equal to 0, which becomes a quadratic equation. First of all, let's simplify. Lambda square minus 3 lambda plus 2 is equal to 0. So the two factors will become lambda minus 1 and lambda minus 2. That means lambda is equal to 1 or 2. So we have option A as our correct answer. Hope you're clear with this. Next is question number 47. If a circle of radius 3 passes through this point and it has the center on this line, then its equation among the following is, first of all, this is the circle. This is the given circle, and let this be the line x minus y minus 1 is equal to 0. X minus y minus 1 is equal to 0. This is the center of the circle, which is given by h comma k. And next, this is the radius. So it says it passes through the point 7 comma 3. So let this be point 7 comma 3. Hope you're clear with the figure. So first, let CHK be the center of the circle. Now, because it CHK, it lies on this line, x minus y is equal, minus 1 is equal to 0. Therefore, since CHK lies on the line x minus 1 minus x minus 5 minus 1 is equal to 0. Therefore, this can be written as h minus k minus 1 is equal to 0, or h is equal to k plus 1. Now, you know that CP is the radius. So, CP is equal to 3, which is given. You can also write down CP square is equal to 9. So, one thing you can see from here that h minus 7 square plus k minus 3 square is equal to 3 square, which is equal to 9, right? So this will become, okay, you have this h is equal to k plus 1. I'll fill in over here. So h is equal to k plus 1. This gives you k minus 6 square plus k minus 3 square is equal to 9. John solving will give you 2k square minus 18k plus 36 is equal to 0. Or you will have k square minus 9k plus 18 is equal to 0. Right? Hope you're clear here. Now next, Okay, over here you are having further. Here, you are given that C becomes equal to 8, comma, minus 2. This is the value of the center of the circle, right? H, K. This is what was the center of the circle. We just found out the value equation. And how does this equation works? You will solve it. This will become question number 47. If a circle of radius r passes through this point and has its center on this line, then its equation among the following is. So you are having this circle. Let's draw first. This is the circle. And the center of the circle lies on this line. This line is given by x minus y minus 1 is equal to 0. So let C be the center with the coordinates hk. Let C be the center having coordinates as h and k. This is lying on this line, and also the radius of the circle is 3, and this circle passes through the point 7 comma 3. So let this point P be the point 7 comma 3. This is point C, and this is the given figure of the problem. Okay, now you have to find out equation among the following. Whose equation it's asking is if a circle of radius 3 passes through this point, center this, then its equation. Okay, we have to find out the equation of the circle. So now one thing, because center, that is HK, lies on this line, lies on the line x minus 1 minus x minus y minus 1 is equal to 0, which gives you x minus k minus 1 is equal to 0, or h is equal to k plus 1. Now you know one thing more, that CP is the radius. CP is radius, and that is equal to 3. Correct? That means if this is the point C and this is the point P, applying the distance formula, CP can also be written as CP can be written as root of h minus 7 square k minus 3 square is equal to 3. H can be written as k plus 1. So this will become k minus 1 square, k minus 6 square, k minus 3 square is equal to 9. This will give you k square plus 36 minus 12k, k square plus 9 minus 6k is equal to 0, which gives you 2k square minus 18k plus 36. Yeah, this was equal to 0 plus 36 is equal to 0. So, or k is equal to k square minus 9k plus 18 is equal to 0, right? This can further, let's split the middle term. So you will get the two factors as k minus 6 and k minus 3 is equal to 0, which gives you the two possible values for k are 6 and 3. You had to find out the center first. So the center, which was given by h and k, this was your point C. So the center can lie, if I'm taking this as, this was h, k. H was equal to k plus 1 and k. So these are the 2 points. So if this is, if I'm taking k is equal to 6, then h will be equal to 7. Or if I'm taking k is equal to 3, then h will be equal to 4. So these are the two possible centers. When I'll take the center as 7, 6, radius is given to be r, then what will be the equation of the circle? Equation will be equal to x minus 7 square plus y minus 6 square is equal to 3 square, or x square plus y square minus 14x minus 12y plus 76 is equal to 0. Similarly, we can frame the equation for 4, 3 also. But fortunately, we have this as one of our answers. That is option C. So we already got our answer. No need to solve for the second one. Option D is the answer to our problem. Correct? Hope you're clear with this. Next is question number 48. Number of circles intersecting x square plus y square is equal to 4, and this orthogonally is. So you are given 3 circles over here. You have to find out number of circles intersecting these 3 circles orthogonally. Correct? Let's write down the equations of the 3 circles. C1 is x square plus y square is equal to 4. C2 can be written as x square plus y square minus 2x minus 3 is equal to 0. C3 can be written as x square plus y square minus 2y minus 3 is equal to 0. So this is equation 1, this is 2 and 3. Correct? So suppose C4, this is the circle whose general equation I can write down, x square plus y square plus 2gx plus 2fy plus c. This be the circle which is orthogonal with C1, C2 and C3. Now, what is the condition for orthogonal? Condition for orthogonal. It is actually 2g, g dash plus f, f dash is equal to c plus c dash. Now, for C1 and C4 circles, g into 0 plus f into 0, this is equal to c minus 4. Right? Similarly, for second and the fourth, C2 and C4, this can be written as G multiplies 0 plus F multiplies 0. No, sorry, this is not C and 4. For circle second and the fourth circle, this can be written as 2G into minus 1 plus F into 0 is equal to 4 minus 3, which will give you minus 2g is equal to 1, or g is equal to minus 1 by 2. This was for the second and the fourth circle. We have done for the first and the fourth, second and the fourth. Now let's go for the third and the fourth. Now C3 and C4. This is equal to 2g multiplied by 0 plus f multiplied by minus 1 is equal to 4 minus 3, which will give you f is equal to minus 1 by 2. Now, what is the radius of C4? That is given as r square is equal to g square plus f square minus c. So, you know, the value of g we just calculated, it was equal to minus 1 by 2, minus 1 by 2 square is equal to 1 by 4. Similarly, minus 1 by 2 square is equal to 1 by 4 for f square. And what was the value of g? C was equal to 4. We just calculated over here. Right? From here, C was equal to 4. So, minus 4, this is on the whole equal to minus 7 by 2. R square is equal to minus 7 by 2, which is less than 0. A square can never be less than 0. Square of any number can never be less than 0. Therefore, no such circle is possible which is orthogonal to these three circles. Since square of any number can't be negative, therefore, no such circle is possible for which is orthogonal to C1, C2 and C3. Okay, let's check with the options. 0, option A. Here, next is question number 49. If the segments of the straight lines x plus y is equal to 6 and x plus 2y is equal to 4 are two diameters of the circle passing through 6, 2, then the equation of the circle is. So let's draw the circle. Here is the circle, and this is the line L1. This is the line L2. So line L1 is x plus y is equal to 6, and L2 is given by x plus 2y is equal to 4, x plus y is equal to 6. These are the two equations of the line. They are the diameters of the circle passing through 6, 2. So this circle is passing, this is the point P, this circle is passing through the point P, which is 6, 2, then the equation of that circle is. So first of all, point of intersection of L1 and L2 is nothing but the center of the circle, right? Now let's solve them. Solving both of them, we will get the center of the circle. So first one was x plus y is equal to 6. Second one was x plus 2y is equal to 4. Let's subtract. So you will have minus y is equal to 2 or y is equal to minus of 2. Similarly, over here, you can find out the value of x because x plus y was equal to 6. So if y is minus 2, x will be 8. So you got the center of the circle as 8, minus 2. Center of circle 8, minus 2. We got the center of the circle. Now, what do we want to find out? Equation of the circle. We got the center of the circle. We know the radius that is given by CP. If I'm taking this C as the center, then the radius is given by CP. This is the center C. CP. For this, C is equivalent to 8 minus 2 and P was given to you as 6, 2. So this CP, this is nothing but the radius. So let's find out. CP is equal to root of 8 minus 6 square plus 2 plus 2 square, which will be equal to 4 plus 16, that is equal to root of 20. Therefore, the equation of the circle, we got the center, we got the radius. Easy to form out the equation of the circle. Equation of the circle can be written as x minus 8 square plus y plus 2 square is equal to root of 20 square, which gives you x square plus y square minus 16x plus 4y is plus 48 is equal to 0. So this is the solution. Let's check with the options. We have option C. Let's confirm. Yes, we have option C as our answer. Hope you're clear. Next question number 50. So again, a circle problem with us. The circle this rolls up along the tangent drawn to it at this point by 2 units. The equation of the circle in the new position is one of these options. That means, see, this was a circle originally. Right? So, here's the point. P, let this point be P, which is forming the tangent 2 plus root 3 and 3. Okay, so this over here, you are having a tangent. Now, it is given that this is the circle. The center of the circle will be given by, see, it's minus 4 and minus 8. Therefore, the center of the circle will be 2, 4. You know that the center is given by minus G minus F. G is half of the coefficient of X and F is half of the coefficient of Y. So here I can have the center C as 2, 4. I hope this is clear. Now this circle rolls along the tangent at this point by 2 units. So that means, first of all, over here, if the circle will roll by 2 units, the new circle will look something like this. It will be something like this. This is the new circle. And this one is the new center. It has rolled up by 2 units. That means this C dash is equal to 2. This point is P and let this point be P dash. This one, where it is meeting the tangent. So I'm assuming this point to be P dash, correct? So this is the one. Let's draw a tangent from here. Perpendicular from here. Right, hope the figure is clear to you. Now the given equation of the circle is x square plus y square minus 4x plus minus 8y plus 16 is equal to 0. So here the C, that is the center, is 2, 4 for the circle. Let's find out the slope of the CP. Slope of the CP, we know the points C and P. C was given by this and P is given by 2 plus root 3, 3. So CP is given by 3 minus 4 upon 2 plus 3 root 3 minus 2, which will give you minus 1 by root 3. This is the slope of CP. CP and C dash, they are perpendicular to each other. Therefore, the slope of CP multiplied by the slope of C dash is equal to minus 1, which gives you the slope of C dash is equal to, see, this was equal to minus 1 by root 3. So slope of C dash will be equal to, let's solve, this will be equal to this, that is, it is equal to root 3, which is actually tangent of 60. Slope can also be written as tangent of theta. So tangent of theta is equal to 60, which gives you theta is equal to 60 degree. That means it's making this line CC dash is making an angle of 60 degree. We know the coordinates of C. Therefore, we can find out the coordinates of C dash. This will be 2 plus 2 cos 60, 4 plus 2 sine 60 degree. Right? Therefore, C dash is equivalent to 3, because cos 60 degree is equal to 1 by 2. Sorry, cos 60 degree is equal to 1 by 2 and sine 60 degree is equal to root 3 by 2. So this will give you 3, 4 plus root 3. Let's find out C dash, P dash. See, this is the same circle. You know C dash, P dash, the radius is not going to change. It will be equal to 2 only. You have to find out the equation of the new circle. You got the center, you got the radius. So it is easy to frame the equation of new circle. What is that? It is given by x minus 3 square plus y minus 4 minus root 3 square is equal to 2 square. Which on, let's open it up, x square plus 9 minus 6y, 6x plus y square. Then let's open this, plus y square, and this is going to be a bit lengthy one. Okay, plus 16 plus 3. Here you will have minus 2. This will be 4y minus, right? This will be 4y, not minus, plus 4y plus root 3y. Plus we multiplied this. Okay, then plus 4 root 3. I think this is the one. Yes. So this will, let's open it up. This is equal to 0. Wait, this is got to be of minus. So let's solve it further. You will have x square plus y square minus 6x minus 2, 4 plus root 3y plus 24 plus 8 root 3 is equal to 0. So this becomes the equation of the required equation of the circle. Let's check. We have option A as our answer. Right? Clear with this? Let's move to the next question. Question number 51. Suppose the angle between the tangents drawn from this point to the circle. This is pi by 2. Then lambda satisfies which of these following equations? So first thing, let's draw the circle. This is the required circle for which we are given this equation, x plus lambda square plus y plus 1 square is equal to lambda square. Now it is given that there is a point O, which is of course the origin. It's given, actually, this is the origin. 0, 0 are the coordinates. So these are the two tangents drawn from O on the circle. Let this point be equal to P and let this be the center. So according to this equation, what is the center? What are the coordinates of the center of the circle? It's minus lambda minus 1. Let's write it clearly. Minus lambda minus 1. These are the coordinates of this center, and let's draw a line OC. So I think the situation is absolutely clear to you. One thing more is given, that the angle between the tangents is pi by 2. So that means this angle, if I'm considering, this whole angle is equal to pi by 2. If this is pi by 2, then this angle is got to be half of pi by 2. That is equal to 45 degrees. All right. So let's write down what we have done till now. Center is given by minus lambda minus 1, and the radius is given by lambda. Right? It's actually, this thing is the radius square. So lambda is the radius of the circle. Correct. Also, one more thing, angle COP is equal to pi by 2. That is 90 degree divided by 2. That is equal to 45 degree. So OP is equal to CP is equal to lambda, right? I think this thing is obviously known to you. OP is equal to CP. Now, how is that possible? See, if I'm drawing this triangle, if this angle is 45 degree, you know this angle, this is 90 degree. The reason, I hope you already know, radius falls perpendicularly on the tangent of the circle. Correct? On the tangent of the circle. So if this angle is equal to 90 degree, then what is this angle equal to? See, this is 45. Let's write it down here. In triangle OCP, angle OPC is equal to 90 degree, angle COP is equal to 45 degree. Therefore, angle PCO is equal to 180 minus 90 minus 45. That is equal to 45 degree. So now this is an isosceles right angle triangle. Triangle OCP is an isosceles right angled triangle. Correct? Also, one thing more, if I want to note down the length of OC, we can use the distance formula, because O is given by 0, 0 and C is given by minus lambda minus 1. So OC will be given by root of lambda square plus 1. Correct? One thing more, if I'm taking, OCP is a right angle triangle. So in triangle OCP, OC square is equal to OP square plus PC square. OC square is equal to lambda square plus 1. OP is equal to lambda, we just discussed it above, plus lambda square plus lambda square. So you will have lambda square is equal to 1. That's it. What do we have to find out in the question? Lambda satisfies. So lambda square is equal to 1. Option A is the correct answer for the question. Hope this is clear. Next is question number 52. If the focus of the parabola is 0, minus 3, and its directrix is y is equal to 3, then its equation is which of these following options? So let's, easy question, not a problem, but just let's make the figure for it. So this is the axis, this is the coordinate axis for the problem, right? These are the two x and y axis. This is y axis, this is the x axis. So you are given that the directrix is y is equal to 3. Let's make that also. This is equal to y is equal to 3 line. So if the focus of the parabola is 0, minus 3. So this is the focus of the parabola. 0, minus 3. Let's denote it by S. So how will you make the parabola? This is something, right, like this. So this parabola is of the form x square is equal to minus 4ay. So here S is given by 0 comma minus a, and in this question we are given that as 0 comma minus 3. Correct. That means a is equal to 3. So easy to find. Equation of the parabola will be equation of the parabola will be given by x square is equal to minus 4 into 3y. Okay. That is equal to minus 12y. So x square is equal to minus 12y. This is option D. So this is the correct answer to the problem. Hope you are clear. Next, question number 53. For alpha belonging to an interval of length beta, suppose alpha comma minus alpha is the interior point on this ellipse. Then this whole equation or expression is equal to. So see, one thing you are given that alpha and minus alpha, they lie inside 4x square plus 5y square minus 1 is equal to 0. So let's fill in the points in this given equation. So you will have 4 alpha square plus 5 minus alpha square will give you alpha square minus 1 is C. If they lie inside this ellipse, then of course this is less than 0. That means 9 alpha square minus 1 is less than 0, or alpha square is less than 1 upon 9. So that means alpha lies between minus 1 by 3 and 1 by 3. This is alpha lies between this. So let's write it down. You can write it as alpha belongs to minus 1 by 3, 1 by 3. Thus, beta will be equal to minus 1, beta will be equal to 1 by 3 plus 1 by 3, that is equal to 2 by 3, right? So what you have to find out? 6 beta minus 4, that's right, 6 beta minus 4 raised to power 201 plus 201. So just have to fill in the values. You can have 6 into 2 by 3 minus 4 raised to power 201 plus 201. This will give you 4 minus 4 raised to power 201, that is equal to 0 raised to power 201 plus 201. The answer will be equal to 201. Hope you are clear with this. So we have option D as our answer, right? Let's move towards the next question, number 54. It says from any point on this hyperbola, tangents are drawn to this hyperbola. Okay. So the area of the figure formed by the chord of contact at that point and its asymptotes is. First of all, you need to be clear with the figure for the problem. Let's make the figure. So here is your x and y axis. So this is your two axes. This is x, this is y and x axis. Correct? So from any point on this hyperbola, let's make the two hyperbolas first. So this is the first one and the second one, right? So question number 54, from any point on this hyperbola, tangents are drawn to this hyperbola. The area of the figure formed by the chord of contact of that point and the asymptotes is. So you are given two hyperbolas. Let this one be H2 and H1, and this one be H2. These are the two hyperbolas given. Let's draw them. This is the coordinate axis. So I'm having this H1 as the first hyperbola, which is given by this equation. So H1 represents, this is the complete hyperbola. H1 is given by x square upon a square minus y square upon b square is equal to 1. This is the first hyperbola. This is the second hyperbola, which is given by H2. Right? This is given by x square upon a square minus y square upon b square is equal to 2. These are the two equations of the two hyperbolas. Now, you have to draw tangents from any point. You're given from any point on the hyperbola, first hyperbola. So I can take this point. Actually, you can take just any point. You are not given any restriction on what type of point you have to take. I'm taking this point A because this is the easiest one to go with. So the coordinates of A will be given by, because this is the equation of the hyperbola. So coordinates of this point A are given by A comma 0. You have to draw two tangents from this point on the second hyperbola. All right. Let's draw it. Okay. So this is somewhat your chord of contact. These are the 2 points of contact, right? This and this. So this is the chord, this line is the chord of contact, right? Hope you are clear with the figure. So it is the chord of contact. Now let's write down equation of chord of contact from A point, which is given by A comma 0 to the second hyperbola, is given by, you know, the equation, general equation for the chord of contact. So according to that, if I'm dropping tangents from this point on the hyperbola, then the chord of contact will be given by the equation A into x upon a square minus 0 into y upon b square is equal to 2, which gives you x is equal to 2a. So this in this case, particular case, this is the equation for the chord of contact, which is given by this line. Here you have x is equal to 2a, right? Next, it's talking about two asymptotes. What are the two asymptotes? Let's draw two asymptotes. Okay, now the figure is getting too many things. So, okay, let's draw the two asymptotes now. Okay, this is point P. And the second asymptote, let it be A1. This is the first asymptote. And the second asymptote, it is given by this. And this is the point Q. Q is the point where the second asymptote A2 is intersecting the chord of contact. And P is the point where the first asymptote A1 is intersecting chord of contact. Okay. Now the equation of the first and the second asymptotes will be given by A1 will be given by y is equal to b upon ax. Here, second asymptote equation will be given by y is equal to minus b upon a into x. Hope you're clear till here. Now you have to find out the coordinates for P and Q. Why is that? Because you have to find out the area of the figure formed by the chord of contact and the asymptotes. Okay, so this particular thing, this particular area, I'm not going to shade this particular area. You have to find out. I hope you can see the cursor. So this particular area you have to find out, which is made by the asymptotes and the chord of contact. Okay. For that, you need to find out the coordinates for P and Q, right? This is the equation of the first chord asymptote. This is the equation of the chord of contact. So let's find out their point of intersection. X is equal to 2a. Let's fill in over here. You will get y is equal to 2b. So if I'm putting x is equal to 2a, what are the coordinates of P? P will be given by the coordinates 2a, 2b. Here, Q coordinates you have to find out. Let's put x is equal to 2a. You will get y is equal to minus 2b. So what are the coordinates of Q? It is given by 2a comma minus 2b. You got the coordinates of P and Q, right? You got these coordinates. Now what do you want to find out? You have to find out the area of the triangle, this one. If I'm naming this as O, you have to find out the area of the triangle OPQ. According to question, or you can say required area is equal to area of triangle OPQ, which is given by half into, see, OM. If I'm taking this as M, this is the perpendicular, right? So this will be given by half into PQ into OM. half into PQ into OM. Right? Now, what is PQ equal to? Let's see it over here. You know the points, P is this and Q is this. So if you look at the coordinates, P is given by 2A comma 2B and Q is given by 2A minus 2B. So that means the distance is given by 4P. So got the PQ, it is equal to 4B. And what is OM equal to? OM is equal to, this is the OM, this is equal to 2A according to the equation. Okay. So OM is given by 2A. Let's solve it. These two will be cancelled and you will have 4AP as the required area. This is what you wanted in the question. So let's check with the options. Here we have option D as the answer to our problem. Hope you're clear with this. If you have anything, any doubts you have, you can rewind this video and watch it again. Let's move towards the next question, question number 55. Okay, this is an assertion and reason question. You have the statement 1. Okay, not an assertion and reason question. These are simply two statements. Statement 1 says the eccentricity of the hyperbola, this is 5 by 4. And statement 2 says the eccentricity of this hyperbola is this. Okay, so you are given two hyperbolas over here, right? Let's solve it. So first hyperbola, the equation is given by 9x squared minus 16y squared minus 72x plus 96y minus 144 is equal to 0. This is the equation of the first hyperbola. Let's solve it. I'll take x term with 9x squared. So I can take 9x common from here. You can have x minus 8x. 9x, no. I'll take, wait. This is 9x squared minus 16y squared minus 72x plus 96y minus 144 is equal to 0. I'll take 9 common. So x squared minus 8x minus 16 common, y squared minus 6y minus 144 is equal to 0. So solving it further, you can say 9x squared minus 8x plus 16 minus 16y squared minus 6y plus 9 minus 144 plus 144 minus 144 is equal to 0. Now what happened over here was I have added 144 at this point and I have subtracted it from here. Similarly, I have subtracted 144 in this second part and I have added 144 over here. Hope you are clear. So simply I'm adding and subtracting 144 in the first two terms. Okay. So now this one can be written as 9x minus 4 whole square 16y minus 3 whole square is equal to 144 because these two will be cancelled. Okay. Now further, you can dividing both sides by 144. So you will get it x minus 4 whole square upon 4 square y minus 3 square upon 3 square is equal to 1. I have divided both the sides by 144. So now over here, if I'm comparing this with the equation of the hyperbola, general equation of the hyperbola. So here A is 4 and B is equal to 3. So the eccentricity will be given by this B squared, which is 3 squared 9, 16, 4 square is 16. This gives me 25 by 16, which is equal to 5 by 4, which is true, which is given us in the equation. So that means we have statement 1 is correct. Also, the eccentricity of this hyperbola, which is x square upon a square minus y square upon b square is equal to 1, it is given by this equation. This is also correct. So both the equations are correct. Statement 1 and statement 2 are true. And statement 2 is the correct explanation for statement 1. That means we have option A as our answer. Hope you're clear with this one. Next is question number 56. The coordinates of the vertices of the triangle are given by these three. Okay, let's draw the triangle first. So here we have the triangle. Okay, this is A, 7, 6, 4, B, 5, 4, 6, and C, 3, 2, 0. These are the three coordinates of ABC. Now it is said bisector of angle BAC meets BC at D. So that means you have something like this. If I'm taking this as theta, then this is also theta because it's saying the bisector of angle BAC meets BC at D. You have to find out the coordinates of D. So now this question will be solved by using the angle bisector theorem. What is that theorem? Let's quickly recap the angle bisector theorem. Angle bisector theorem says that angle bisector of a triangle divides the opposite side into two parts proportional to the other two sides of the triangle. Okay, so now according to this theorem, what you can say is AB upon AC is equal to BD upon CD. Right? What is AB? You know the coordinates of A, B, and C. So according to that, AB is given by 7 minus 5 square root of 7 minus 5 square, which is equal to 2 square, plus 6 minus 4, that is 2 square again, plus 4 minus 6, which is minus 2. Minus 2 square is like this. So you can write it as 4 plus 4 plus 4, which is equal to root of 12. And this can be written as 2 root 3, right? AC, it can be written as AC, you have 7 minus 3. So 7 minus 3 is 4, 4 square, plus 6 minus 2, which is again 4 square, plus 4 minus 0, which is again 4 square. So this will be equal to 16 plus 16 plus 16, that is equal to root of 48, which is equal to 4 root 3. Okay, so these are the two distances AB upon AC. Let's fill it over here. So you have 2 root 3 upon 4 root 3 is equal to BD upon CD. So you will have a cancellation. This is equal to 1 by 2, right? So that means D is dividing BD and DC in the ratio of 1:2. Therefore, D divides BC in the ratio of 1:2 internally. So D will be given by B coordinate C, 5 into 2, that is 10, plus 1 into 3, which is 3, that is 10, plus 3 upon 1 plus 2, which is 3. Similarly, 4 into 2, 8, plus 2 into 1 upon 3, then 12 plus 0 upon 3. That means D will be given by 13 by 3, 10 by 3, and 4. So you got the coordinates for D as this. Now let's check with the options. What do you have in the answer? 13 by 10, 13 by 3, 10 by 3, 4. You have option A as the answer to our problem. Hope you're clear with this. Let's move to the next question, number 57. It says if the direction cosines of a line satisfy this equation and this equation, then the direction cosines of the line are, 4 options are given. You have to find out the correct one. Okay. So because L, M, N, they are the direction cosines, L, M, N are direction cosines of any line. So they will satisfy this equation. L square plus M square plus N square is equal to 1. You are given two equations. First is L minus M plus N is equal to 0. And the second one is L into M plus M into N minus 4NL is equal to 0. Here you can have L is equal to M minus N. Okay. So the second one, I'll fill this value of L in this equation. So this equation will become M minus N into M plus M into N minus 4N M minus N is equal to 0. So M square minus M into N plus M into N minus 4mn plus 4n square is equal to 0. They will cancel out each other and you'll be left with m square plus 4n square minus 4mn. Now this is a perfect square for m minus 2n whole square is equal to 0. That means m will be equal to 2n, which will give you L is equal to 2n minus n, that is equal to n, right? I hope you're clear till here. So you got the value of m and L, right? Now you have this equation, this first one. From 1, you can say L square, which is equal to n square now, plus 4n square, which is, you had this equation, right? L square plus m square plus n square is equal to 0. So plus n square is equal to 0. Sorry, not 0. It is equal to 1. Right? So this gives you 6n square is equal to 1, or n will be equal to plus minus 1 by root of 6. Therefore, m will be equal to plus minus 2 upon root of 6. And L will be equal to plus minus 1 upon root of 6. So these are the three values. Now the direction cosines will be given by, direction cosines are 1 by root 6, 2 by root 6, 1 by root 6. This is the first one. And minus 1 by root 6, minus 2 by root 6, and minus 1 by root 6. So these are the two direction cosines. Let's check. We don't have the first one. No, no, yes. We have option D as our answer. Hope you're clear with this. Then let's move to the next question. Question number 58. Let phi be the plane passing through this point and perpendicular to the line which is joining these 2 points. If the equation of the plane containing these 2 points and perpendicular to the plane phi is given by this equation, then you have to find out the value of 3 brackets A plus C. First thing, you are given plane phi passes through 3, minus 3, and 1. And it is perpendicular to these 2 points, line which are joining to the line joining 3, 4, minus 1, and 2, minus 1, 5. right? Now the direction cosines of the normal to the plane are given by direction ratios, not cosines. Direction ratios of normal to the plane are given by 3 minus 2, 4 plus 1, minus 1, minus 5, which is equivalent to 1, comma 5, comma minus 6. These are the direction ratios of the normal to the plane. Let's draw it over here. So it will be clear to you. This is the plane, right? So this is the line which is joining the 2 points. First one is 3, 4, minus 1, and the second one was 2 minus 1, 5. And this is the point which is lying on the plane. This is given by 3, minus 3, and 1, right? So let's see it further what you are given. Yes. Okay. Now equation of the plane pi will be given by equation of plane pi according to these direction ratios will be given by x plus 5y minus 6z plus t is equal to 0. Now you know that pi passes through this point. Pi passes through 3 minus 3, 1. So this will be 3 plus 5 into minus 3 minus 6 into 1 plus d is equal to 0, which will give you d is equal to 18. Right? Now the equation of plane pi is equivalent to x plus 5y minus 6z plus 18 is equal to 0. Now the second thing, there is one more plane, equation of the plane which is passing through this point, which is containing these 2 points, is given by this. Now, equation of the plane containing points 3, 4, minus 1 and minus 1, 2, 5 is ax plus y plus cz minus d is equal to 0. Let's make it over here. So this is the plane, right? Okay. This is the plane and these are the 2 points, 3, 4, minus 1 and minus 1, comma 2, comma 5. These are the 2 points which are lying on the plane. Also, you are given that there is a normal to the plane. Okay. So the equation of the plane which is containing these 2 points is given by this. Now let's name this as number 1. Hope you are clear till here. Now you are given that there is a normal also to this plane. So normal to this plane will be perpendicular to the line joining points 3, 4, minus 1, minus 1, 2, 5, right? Then you have a into 3 plus 1 plus 1 into 4 minus 2 plus c into minus 1 minus 5. This is equal to 0. I'm using this equation, right? So you will have 4a plus 2 minus 6c is equal to 0. So you have 2a plus 1 minus 3c is equal to 0. Now let's number this one as 2. All right, hope you're clear. So now, okay, plane pi and equation 1, this one, they were perpendicular. So you have a plus 5 minus 6c is equal to 0, which gives you a is equal to 6c minus 5. So this is number 3. Now let's put this one in this equation. So you will have 2 into 6c minus 5 plus 1 minus 3c is equal to 0. 12c minus 10 plus 1 minus 3c is equal to 0. 9c minus 9 is equal to 0, which gives you c is equal to 1. Now let's put this c is equal to 1 in the third equation. So put c is equal to 1 in the third equation. You will get a is equal to 6c minus 5, which gives you 6 into 1 minus 5, that is equal to 1. So that means a is equal to 1. So a is equal to c is equal to 1. Now let's put this one in equation 1. Put this in equation 1. So if you will put, you will get x plus y plus z minus d is equal to 0. Now, you know, this plane passes through this plane passes through -1, 2, 5. So this will be -1 plus 2 plus 5 minus d is equal to 0. This is equal to 6. That means d came out to be 6, right? What do you have to find out in the question? Let's go to that. You have to find out the value of 3a plus c. Actually, 3a plus c we already know. 3a plus c, this is equal to 6. But there is no option 6. We have the answer in terms of d everywhere, right? That means let's go it with the d thing. So 6 is d only. That means 3a plus c is equal to d, nothing. 3a plus c is equal to d. This is the answer to our question. Now let's check with the options. What do you have? We have option C as our answer. Hope you're clear with this, right? Let's move to the next question. Okay. So next is we have question number 59. It says if this denotes the greatest integer function, then you have to find out the value of this equation, expression rather. Okay, so you are given limit x approaching pi by 2 plus sin x minus cos x upon 2, that is plus 1. So one thing, if you have for x greater than pi by 2, the value of sin x and cos x. For sin x will lie between, it will be greater than equal to 0 but less than 1. Similarly, cos x will be greater than equal to -1 but less than 0. Okay, so now let's fill in. You will get limit x approaching pi by, okay, I don't need to write this one now. So I'll just fill in the values. This will be 0 minus -1 upon plus 1 upon 2. So this will be equal to 2 upon 2, which is equal to 1. Pretty easy question. We have option D as our answers. Right? Done. Clear. Next is question number 60. So before moving to this question, students, if you want to practice all these and many more entrance exam question papers, then do visit our website www.examsnet.com. You can also download our app. You have the link in the description box. Best of luck. Let's move to next question. That is question number 60. If a is not equal to 0 and x is greater than 0, then you have to evaluate this expression, which is limit n approaching infinity cos x minus e raised to power nx divided by 1 minus a e raised to power nx. Okay. Now what I'll do, I'll divide numerator and the denominator with e raised to power nx. Let's go. So this makes limit n approaching infinity. You have cos x upon e raised to power nx minus 1 upon e raised to power nx minus a. Okay. Now, you know one thing, for all the real values of x, you have the value of cos always lies between -1 and 1, right? So therefore, you can write this one as when n is approaching infinity, this will be equal to 0, -1 upon e raised to power, when you will have x approaching infinity, this will also become 0 minus a. You have -1 upon minus a, which is equal to 1 upon a. Easy as that. So we have option D as our answer. Done? Clear? Next is question number 61. It says let fx is equal to limit y approaching infinity, y into x raised to power 1 upon y minus 1 and 2022 f 1 upon x is plus p fx is equal to fx squared, then p is equal to. So big equation you have. Let's simplify it. You are given that fx is equal to limit y approaching infinity, y x raised to power 1 minus y minus 1 and 2022 f of 1 by x plus p of fx is equal to fx squared, right? Now, let's go with fx. You have this is equal to limit y approaching infinity, x raised to power 1 minus y. This y now can be written as 1 upon y, right? Let's put y is equal to 1 upon t. So as y will approach, as y approaches infinity, then t approaches 0. So you have fx is equal to limit t approaching 0, x raised to power t minus 1 upon t. Here we will be applying L'Hospital's rule. So now using L'Hospital's rule, you will have fx is equal to limit t approaching 0. So here what we had x raised to power t. So this will be x raised to power t natural log x. 1 is a constant, so the derivative will be 0. Similarly, t derivative will be 1. So you will have, when you will solve this limits, putting t is equal to approaching 0. So x raised to power t, that is x raised to power 0, will be 1 into log of x minus 0 upon 1. So this will remain as such, natural log x. Hope you are clear with this. So now f of what you had over here, f of 1 by x. F of 1 by x will be given by natural log 1 by x. So this is equal to minus natural log of x. Now 2022 f of 1 by x plus p of fx is equal to fx squared. This was originally given. So now let's fill in 2022. This is equal to minus natural log x plus p into natural log x is equal to natural log of x square, right? So you will have it over here as minus natural log x, minus natural log x, which can be written as this, plus p into this is equal to 2. This x will come, this 2 will come over here, 2 into natural log x. So minus 2022 plus p is equal to 2, or p is equal to 2024. This is what you have to find out in the question. P is equal to 2024. Option D is the answer to our problem. Hope you are clear. Let's move to the next question, number 62. It says if y is equal to sine of 2 tan inverse this whole thing, x is equal to cos 2 theta, then the derivative of y, first derivative of y with respect to x is given by. So you are given y is equal to sine of 2 tan inverse 1 minus x upon 1 plus x. X is equal to cos 2 theta. Then 1 minus x upon 1 plus x. This can be written as 1 minus cos 2 theta upon 1 plus cos 2 theta. This is equal to 2 sine square theta upon 2 cos square theta, which is equal to tan square theta, right? So tan inverse of 1 minus x upon 1 plus x can be written as tan inverse, because this was the root of this. So this will be tan inverse tan of theta. That is equal to theta only, right? So y becomes, this original equation, it becomes y is equal to sine 2 theta. Derivative dy by dx can be written as dy by d theta upon dx by d theta. So this is equal to d sine 2 theta upon d theta multiplied by 1 upon derivative of cos 2 theta upon d theta, right? They will cancel out, d theta will cancel out, and you will be left with, so derivative of sine 2 theta, this is 2 cos 2 theta upon minus 2 sine 2 theta, which is equal to minus cot 2 theta. So dy by dx will be given by this thing. Let's check with the options. Here we have option B as the answer to our problem. Hope you're clear. Let's move to the next question. Question number 63. If fx is equal to modulus of x square minus 3x plus 2, then df upon dx is equal to what? So you are given the function as the modulus of x square minus 3x plus 2. Let's factorize this one. You can write it as x minus 1 into x minus 2 mod. Now one thing, this is the mod function, right? So that means fx, this can be written as positive of x minus 1 into x minus 2 if x is less than 1 and greater than 2. And it will be a negative of x minus 1 and x minus 2 if x lies between 1 and 2, right? So that means simply you have this function fx is equal to modulus of x squared minus 3x plus 2 if x is less than 1 and greater than equal to 2, and minus x squared plus 3x minus 2. See, what I'm doing is nothing but I'm taking the negative of this whole expression when x lies between 1 and 2. Hope this is clear, right? So let's take you have to find out df by dx, which is nothing but the derivative, first derivative of the function with respect to x. This can be written as modulus of, modulus. This is simply for the first and the second one. This will be written as 2x minus 3 when x is less than 1 and greater than equal to 2. Also, minus 2x plus 3 when x lies between 1 and 2. So let's check with the options what we have. We don't have the 1 as the option. No, this is wrong. This is wrong. Yes, this is correct. 2x minus 3 when x is greater than 2. This is satisfying our answer. So option C is the correct answer. Hope you're clear with this. Next is question number 64. It says if y is equal to log x upon x, then you have to find out the second derivative. Okay. So let's go with the question. Let's write it down. You have y is equal to log of x upon x. You can also write down xy is equal to log of x. Now let's find out the derivative of it. So now x is the first function, y becomes the second function. So first function derivative of second, x into dy by dx plus y into 1 is equal to log x can be written as 1 upon x. So that means dy upon dx is equal to 1 upon x minus y whole multiplied by 1 upon x, right? So let's name this one as equation 1. Okay, so let's find out the second derivative which we have to do. So from equation 1, let's go with the second derivative. So now this is the first function. This x is the first function and this is the second function. First function into derivative of second plus second function into derivative of first. So x derivative is 1. I'll keep it as such. And this is equal to dy by dx is equal to minus 1 by x squared. Derivative of 1 by x is equal to minus 1 by x squared. Hope this is clear till here. So now x into second derivative of the function plus 2, it was dy by dx, right? So I'll pick it up from here, this value, and fill at this place. Okay, so this will become twice of y twice because I'm adding both of them. 1 by x minus y into 1 by x is equal to minus 1 by x square, right? Which further, so this is the second derivative, x into d square y upon dx square is equal to minus 1 by x square minus 2 into 1 by x into 1 by x minus y. You have to find out the second derivative at x is equal to 1. So second derivative at x is equal to 1. 1 into d square y dx square is equal to minus 1 upon 1 minus 2 1 upon 1 1 upon 1 minus y. So when I'm saying here y, so this will become, see, y was equal to log x upon x, correct? And I'm putting this as 1, so this will be y is equal to log of 1. I'll fill it in this portion. So this is equal to 1, right? And this will cancel out. You will have question number 64. It says if y is equal to log x upon x, then the second derivative of y with respect to x at x is equal to 1 is equal to which of these following options? So you are given y is equal to log of x upon x, which can be written as x, y is equal to log of x. Let's find out the derivative. So here this will be the first function. This is the second function. Derivative will be given by first function into derivative of second plus second function into derivative of first is equal to log of x. The derivative of log of x is equal to 1 by x. Let's name it as number 1. Now this can be written as dy by dx is equal to 1 minus x into y minus y into 1 upon x. So these are the two equations, right? Now I'll pick up the first one and then I will find out the first derivative or second derivative, sorry. So let's pick up this one. Let's find out the second derivative. So x into derivative of this first function derivative of the second plus second function into derivative of first plus dy by dx is equal to minus 1 by x square. 1 by x, the derivative of 1 by x is equal to minus 1 by x square. Okay, so x into d square y upon dx square plus 2 dy by dx is equal to minus 1 by x square. Now I will use second equation to fill over here the value of dy by dx. So from 2 x into d square y upon dx square plus 2 into 1 by x minus y into 1 by x is equal to this. Now you have to find out the second derivative at x is equal to 1. It's given in the question, right? Let's go. So at x is equal to 1, this can be written as 1 into second derivative of the function plus 2 into 1 by 1 minus y. So now what is the value of y? You know y was equal to log of x upon x, which is equal to log of 1 upon 1. Log of 1 is equal to 0. So that means at x is equal to 1, y is equal to 0. So this will be like this is equal to minus 1 upon 1. So this will be second derivative plus 2 is equal to minus 1. So the second derivative will be equal to minus 3. Right? Let's check with the options. We have option B as the correct answer. Hope you're clear. Next is question number 65. It says the angle made by the tangent at theta is equal to pi by 3 on the curve x is equal to a brackets theta plus sine theta, y is equal to a brackets 1 minus cos theta is equal, with x-axis is equal to what? So you are given two things. X is equal to a theta plus sine theta. Second is y is equal to a 1 minus cos theta. Let's find out the derivative of x with respect to theta. You will have a1 plus cos theta. Here you will have dy by d theta is equal to a. One derivative is 0. So cos theta derivative is minus sine theta. Minus minus will be plus. So plus sine theta. I have dx by d theta and dy by d theta. You have to find out dy by dx. This will be given by dy by d theta upon dx by d theta. That means this is equal to a and a will cancel. I will not write it down. So sine theta upon 1 plus cos theta. Now read the question again. It says the angle made by the tangent at theta is equal to pi by 3 on this curve with x-axis is. So at theta is equal to pi by 3, dy by dx is equal to sine pi by 3, 1 plus cos pi by 3. Sine pi by 3 is given by root 3 by 2 upon 1 plus 1 by 2. So when you will solve this whole thing, root 3 by 2 upon 3 by 2. So you will get 1 by root 3, which is equal to tan pi by 6, right? So dy by d theta, this is nothing but the tangent of theta, right? That means theta is equal to pi by 6. Right? Let's check with the options. I have option B as the answer. Hope you're clear with this. Let's move to the next question number 66. It says if the angle between these two curves, what is the first curve? Y square is equal to 4x and y is equal to e raised to power minus x by 2 is theta. Then cosecant square theta by 2 is equal to. So you are given two curves. Y square is equal to 4x and y is equal to e raised to power minus x by 2. Let x1, y1 be the point of intersection of both the curves. Let x1, y1 be the point of intersection of both the curves. Now you have y square is equal to 4x. Let's find out the derivative. So dy by dx, this is actually 2y, dy by dx is equal to 4. You will have dy by dx is equal to 2 upon y. Right? Now, first slope, that is m1. This is equal to dy by dx at x1, y1. So this is equal to 2 upon y1. Now let's take the second one, which is equal to y is equal to e raised to power minus x by 2. Dy by dx is minus 1 by 2 e raised to power minus x by 2. Second slope at x1, y1 is equal to minus 1 by 2 e raised to power minus x1 by 2. This is equal to minus 1 by 2 y1. Right? Now, you are given that theta is the angle between the curves. Given theta is the angle between them. Right? So that means, what is tangent theta? That is equal to m2 minus m1 upon 1 plus m2 into m1 into m2 modulus. Now I just have to fill in the values. We got everything. So minus y1 by 2 minus 2 upon y1 whole divided by 1 plus minus y1 upon 2 multiplied by 2 upon y1. Right? So this will be equal to, when you will solve it, see this is 1 minus 1, right? Denominator is having 1 minus 1, which gives me infinity. Therefore, what is like this can be given by tan of pi by 2 only. So that means theta is equal to pi by 2, right? What do you have to find out? Let's see the question once again. Cosecant square theta by 2. So now easy. You got the value of theta. It's easy to find out cosecant square theta by 2. Cosecant square theta by 2 is equal to cosecant, theta by 2 it was. So cosecant square pi by 2 on this. So cosecant square pi by 4, which is equal to root 2 square or 2. So that means we got our answer. Let's check. We have option A. So this is the answer to our question. Hope you are clear. Let's move to the next question, number 67. Okay. Now it is asking you x lies between 0 and pi by 2. Then which of the following options is correct? So I'll do what? I'll pick up the sin x first. So I'm consider fx is equal to sin x upon x. Now let's take the first derivative. So first derivative, you know this, the formula. You have x square over here. So x into derivative of sin x, it is equal to cos x minus sin x into derivative of x, that is equal to 1. So now I'll take the numerator. Let ux is equal to x into cos x minus sin x Okay, I'm taking the numerator only. Now let's find out the derivative of the first derivative of the numerator. Okay, actually, I want to know what type of function it is. Is it a decreasing or a decreasing function? So for that, first step is, let's take the first derivative of the function. So this will be given by minus x into sin x plus cos x minus cos x. They will cancel out. Okay, now only you're left with only minus x sin x. Now let's go for the second derivative. Okay, so okay, I don't need to go for the second derivative. It's okay. That's okay. First derivative is equal to minus x sin x, right? Now this thing is less than 0 for all x belonging to 0 to pi by 2. This gives me that, therefore, this ux is a decreasing function. Okay, why? Because x is greater than 0 and ux is decreasing, right? Therefore, ux is less than u0 is equal to 0. Thus, first derivative is less than 0. Therefore, fx is a decreasing function. If I'm taking this one, this is less than 0. Therefore, fx is also a decreasing function. Right? Because x lies between 0 to pi by 2. Okay. So, f of pi by 2 is less than f of x is less than f of 0. That simply means 2 upon pi is less than sin x upon x is less than 0. So let's check with the options. Option 1 is not correct. Yes. Option 2 is the correct answer. Option D. Hope you're clear with this. Next is question number 68. Okay, it says the least intercept made by a tangent to this ellipse with coordinate axis is. So pretty easy question, right? You are given the equation of the ellipse. Okay, that means, you know, the general equation, it's x square upon a square plus this is equal to 0. So this can be written as x square upon 8 square plus y square upon 7 square is equal to 1. From here, I get 8 is equal to 8. B is equal to 7. Now, when the intercept is made by the tangent on the coordinate axis is minimum, then the least value of the intercept will be, wait, I'll write it down. When the intercept made by the tangent on the coordinate axis is minimum, because it is said in it has said you in the question the least intercept is minimum, then least value of intercept is 8 plus 7, that is equal to 15. Correct? That means we have option C as our answer. You had to find out the least intercept. So the least intercept will be given by, in this case, it will be given by A plus B. Hope you're clear with this. Then let's move to the next question. Question number 69. If fx is equal to root 3 sin x minus cos x minus 2ax plus b decreases for all values of x, then which of the following is true? So you have fx is equal to root 3 sin x minus cos x minus 2ax plus b. Let's find out the first derivative. So this will be given by root 3 cos x derivative minus 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 plus. So minus plus sin x minus 2a. I'll take the 2 common. So this can be given by root 3 by 2 cos x plus 1 by 2 sin x. I'll take 2a separately outside. Okay. So this can be written as actually root 3 by 2 and okay. So root 3 by 2 can be written as sine pi by 3 cos x plus cos pi by 3 into sin x minus 2a. So this is 2 sine x plus pi by 3 minus 2a. Now in the question it is said you if fx decreases for all values of x. Now when fx decreases, then the first derivative is less than equal to 0. That means 2 sine x plus pi by 3 minus 2a is less than equal to 0. That means 2a is greater than 2 sine x plus pi by 3. This gives you 2 will cancel. That is a is greater than sine x plus pi by 3. Right? So we have one thing because sine, one thing, sine x plus pi by 3, this is less than equal to 1. So comparing both these equations, you have a is greater than equal to 1. That means we got our answer. Yes, we have option A. Hope you're clear. Next is question number 70. Okay, so now we have an integration problem with us. It says if integral of this function is equal to k of x plus L log this whole expression plus c, then k plus L is equal to. So basically you have to find out the value of k and L. Let's go with this. So let's first of all put this I is equal to integral of 3 e raised to power x minus 7 e raised to power minus x upon 7 e raised to power x plus 3 e raised to power minus x dx. This is what we are given in the question. Okay, I'll take the 3 outside. So you have 3 e raised to power x minus 7 by 3 e raised to power minus x whole divided by 7 this, right? So I'll take the 7 common from the denominator. Now I will have I'll multiply this one, the numerator, with 7 now. Okay, so this will be 7 e raised to power x minus 49 upon 3 into e raised to power minus x, and I will not touch the denominator. It will be as such. Hope you're clear till here. Now further, 3 by 7, 7 e raised to power x plus 3 e raised to power minus x minus 58 upon 3 e raised to power minus x whole divided by 7 this e this into dx. Okay, so now I'll open up the brackets. 3 by 7 dx, right? What will happen? I have opened up the bracket, so this is equal to dx minus 3 by 7 into 58 by 3 integral of e raised to power minus x 7 e raised to power x plus 3 e raised to power minus x dx. Hope this is clear what we have done till now. See, here was 49 by 3. I have split that one using that I want this bracket to have 7 e raised to power x plus 3 e raised to power minus x so that the numerator and the denominator may cancel. And I will keep this part, like I have split this whole term in 2 parts. Right? The first one will be 1 into dx and the second one will be 3 by 7 into 58 upon 3 e raised to power minus x upon 7 e raised to power x plus 3 e raised to power minus x, right? So this will become 3 by 7. Now integral of 1 is equal to x. I'll write it as such. And here you will have this cancellation and no further cancellations are there. So this will be minus 58 upon 7. And now over here, what I'll do, I'll divide the numerator and the denominator with e raised to power x. So you will have e raised to power minus 2x upon 7 plus 3 e raised to power minus 2x into dx. I will put t is equal to 7 plus 3 e raised to power minus 2x. Let's find out the derivative. Dt is equal to minus 6 e raised to power minus 2x dx. So this I will pick up this one. This was equal to 3x minus 7 upon 58 upon 7 minus 1 by 6 into 1 upon t dt, right? This can be further written as 3x upon 7 minus 58 upon this. So cancelling, you will have it as over here, this is 29. Here you have 3. So this will be plus 29 upon 21. And 1 upon t, its integral will be equal to natural log t. Okay, yeah. So plus c, that is the constant. 3x plus upon 7 plus 29 upon 21 natural log of 7 plus 3 e raised to power minus 2x plus c. So comparing it with the one we have over here, you can easily find out the value of k and l. So according to this, k is equal to 3 by 7 and L is equal to 29 by 21. You have to find out k plus L, that is 3 by 7 plus this, which on solving will give you 38 upon 21, right? So this is the answer to our question. Let's check. 38 upon 21 is option C. So here we have the answer to our problem. Okay, hope you're clear with this. Next is question number 71. So you are given if, okay, fine. You have to find out this whole expression dx is equal to what? So that means you have to find out the integral. Actually, you have to find out the integral of this function, right? So let this one be I. I'm assuming this whole expression to be equal to I, and I'll put this one 12x minus 36 as t square. So 12x minus 36, I'll say it as x is equal to t square upon this, right? And over here you can have 2t dt is equal to 12 dx, which gives you t dt is equal to 6 dx, right? Now I'll fill in this whole thing in the original integral. I'm assuming this one to be the integral. So I will be given by integral of root of t square plus 36 upon 12 plus t plus root of t square plus 36 upon 12 minus t, right? This whole into t by 6 into dt, right? So integral, this integral, let's solve it further. This integral will be equal to 1 by 6 integral of, on solving this whole thing, you will have root of t square plus 36 plus 12t upon 12 plus root of t square plus 36 minus 12t upon 12. This whole multiplied by t multiplied by dt, right? So this is nothing but this is integral of root of t plus 6 square upon 12 plus t minus 6 square upon 12 into t into dt. This whole is multiplied by this. Okay, so now this can be written as 1 by 6 integral of t plus 6 upon root 12 plus t minus 6 upon root 12 t dt. This will be equal to 1 by 6 and 6 and 6 will cancel. So you will have 2t upon root 12 into t into dt. So this will be 2 by 6, which will be 1 by 3. This whole on solving will give me 1 upon 3 root 12 integral of t square into dt. 1 upon 3 root 12. T square integral is given by t cube upon 3 plus the constant. So you will have this as 1 by 9 root 12 t raised to power 3 plus c. Right, now let's fill in the value of t. What we had in the value of t? This is equal to 1 by 9 root 12 into 12x minus 36 raised to power 3 by 2 plus the constant. Right, so this will be given by 12 raised to power 3 by 2 upon 9 12 raised to power 1 by 2 into x minus 3. I have taken the 12 common from here. Okay, and inside I'll be left with x minus 3 raised to power 3 by 2 plus c, which on solving further will give me, see, this is root 12 and over here I'll be left with 12 upon 9 only. X minus 3 raised to power 3 by 2 plus c. So this will be 4 by 3 x minus 3 raised to power 3 by 2 plus c if x is greater than 6, right? So now further, what you had in the question is this. Okay, so now further, now I is equal to 1 by 6 root 12 integral of t plus 6 minus t minus 6 t dt. Now this is when x is lying between 3 and 6. See, what happened was actually when we were solving this thing, we were over here when we made the squares, right? So this part, this was when t square is greater than 36, right? So we have the two conditions. That is, first thing was, this is true when x is greater than 6 and this is true when x lies between 3 and 6. Okay, so this is equal to 6 root 12 brackets. Now the t's will cancel and you will have 12 t dt. So simple as that. Now you will have root 12 upon 6 into t square upon 2 plus c. Correct? So you will have here, now this is 12 again. So I will have 1 by root 12 over in the denominator once again. And t square, t square is equal to 12x minus 36 plus, I'll keep it in c dash because earlier we took c. So now it will be c dash. So this is equal to root 12x plus minus 36 upon root 12 plus c dash, right? So therefore the integral is equal to 2 root 3x plus c if x is lying between 3 and 6, right? So hope you're clear with this. Let's check with the options. What we have in the answer is, yeah. So if it is greater than 6, now then you have it as 2 root 3, this x plus 6. Wait, just let me confirm. Sorry, this is equal, this is when x is greater than 6. Okay. So yes, when x is greater than 6, then the integral is this. And when it lies between 3 and 6, then the value is this. So let's check with the options. Here we have option, no, not the D1, but I have, let me confirm. Question number 71. So now this is an integral problem. Actually, this is equal to I. So you have to find out the integral of the function. This is the whole root thing plus the whole root thing. Dx is equal to some integral function I. You have to find out the value. Okay. So very first thing, I'll put this term 12x minus 36 is equal to t square. So the value of x can be written as t square plus 36 upon 12. Let's find out the derivative. So this can be written as dx is equal to, I'm taking 12 over here, okay? So 12 dx is equal to 2t into dt, okay? So that means you have, this can be written as dx is equal to 1 by or t by 6 into dt. Right, this thing is clear. So now I'll fill in the values in the given integral, right? You know the given integral, I'll just fill in the values. So the integral can be written as, in this case, this will be root of t square plus 36 upon 12 plus t plus t square plus 36 upon 12 minus t into dt. This whole thing will be multiplied, right? So now let's solve it further. Integral is equal to t square plus 36 plus 12t root upon 12 plus t square plus 36 minus 12t upon 12 whole multiplied by t into dt. So integral will be given by, this is equal to t plus 6 square upon root 12 square. Sorry. Whole root plus t minus 6 square upon root 12 square into t into dt. Right? Okay. So now this can be written as integral t plus 6 upon root 12 plus t minus 6 upon root 12 into t into dt. So now there is one more thing. This thing is when t square is greater than 36. This is valid if t square is greater than 36. So one thing more, I forgot there was a 6 over here. Yes, this 6 was over here. So here is 6. Here is 6. Here is 6. And I have taken that 6 outside in this case. Now this can be written as 1 by 6 root 12 into t plus 6 integral of t plus 6 plus t minus 6 whole multiplied by t dt. Correct? So this is equal to 1 by 6 root 12. 6 and 6 will cancel. So this will be equal to 2. I'll take outside t square dt. So 1 by 3 root 12 into t cube upon 3. This will be 1 by 9 root 12 into t cube. So what was t equal to? I'll fill in the value of t now. T was equal to 12x minus 36 raised to power 3 by 2 plus the constant. Okay. Here was the constant which was introduced. So let's solve it further. So you will have it as, I'll take the 12 common now. 12 raised to power 3 by 2 upon 9 into 12 raised to power 1 by 2 into x minus 3 raised to power 3 by 2 plus c. So this will be equal to 12 upon 9, which is equal to 4 upon 3 into x minus 3 raised to power 3 by 2 plus c. This is the case when x is greater than 6, right? Now the second one, I'll take that integral back again. Now if x lies between 3 and 6, then the integral will be given by 1 upon 6 root 12 integral of t plus 6 minus t minus 6 t dt. So this is equal to 1 upon 6 root 12. Now the t's will cancel and you will have integral of 12 t dt. So 12 will be taken outside. You will have 2 upon root 12 into integral of t will be t square by 2 plus c dash. I hope you're getting everything, right? So 2 upon root 12 and t was equal to 12x minus 36. So t square was equal to 12x minus 36. So 2 again, here is 2. It will cancel actually. Okay. Yeah. So you will have this 2 will get cancelled. There was a multiply sign. I'll write it. It will cancel plus c dash. So you have 12x upon root of 12 minus 36 upon root of 12 plus c dash. This is the whole constant, right? So I'll keep it as such. You will have root 12x plus, sorry, minus. I'll take it as plus over here and minus over here. So minus 36 upon root 12 plus c dash. This is the whole constant, right? I'm ignoring it. So this integral was equal to 2 root 3 x plus some constant c dash. If x lies between 3 and 6. So now let's go to the options. We have two answers, right? This is the first one when x is greater than 6, and this is the second one when x lies between 3 and 6, right? So let's check with the options what we have. Option C is satisfying our answer. So this is our answer to the question, option C. Hope you're clear with this. Let's move to the next question, number 72. So it says integral of x dx upon this whole thing is equal to a into 1 plus x square upon 2 plus x square raised to power 1 plus n plus c. Then n upon, this is alpha. Yeah. Then n upon alpha. This is alpha, not a. This is a. Okay. Whatever it is, it's just that variable. Okay. So let's write down the integral is equal to x dx upon root of 15 root 1 plus x square raised to power 12, 2 plus x square raised to power 18 is equal to this. Plus some constant, right? So this can be written as x dx 1 plus x square raised to power 12 upon 15 into 2 plus x square raised to power 18 upon 15. X into dx 1 upon 1 plus x square 4 upon 5 2 plus x square 6 upon 5. This further can be written as integral of x into dx 1 plus x square whole square 2 plus x square upon 1 plus x square. Now I'm collecting it raised to power 6 plus 5, 6 by 5. Okay. Now I will put this whole expression, this one, equal to u. Put u is equal to 2 plus x square upon 1 plus x square. That means du will be given by 1 plus x square whole square. So this is equal to 1 plus x square into 2x minus 2 plus x square into 2x dx. Du is equal to, okay, so du is equal to, I'll open up, this will be 2x plus 2x cube. Okay, I'll take 2x common from here. I'll not open this way. 2x 1 plus x square minus 2 minus x square upon 1 plus x square dx. So these two will cancel and I will have minus 1 minus 2 gives you minus 1. So minus 2x upon 1 plus x square dx. Correct? So x dx upon 1 plus x square is equal to minus du upon 2. Okay. Now, integral, what we left over here, this one. Okay. This integral will be, this I will become 1 by 2 integral of dx upon u raised to power 6 by 5. So this is equal to minus 1 by 2 u raised to power minus 6 upon 5 plus 1 upon this plus c. This gives me 5 by 2 into u raised to power minus 1 by 5 plus c. I'll put the value of u now. 5 by 2 into 1 plus x square 2 plus x square raised to power 1 by 5 plus c. Right? I did the reciprocal of the numerator and denominators and also changed the sign of the power. So here it was alpha is equal to, looking at them, 5 by 2. See over here, this is equal to alpha, right? And n. So comparing that, alpha is equal to 1. This is equal to 5 by 2 and n is equal to 5, right? It was equal to 1 by n. So n is equal to 5. What do you have to find out? N upon alpha. So n upon alpha will be given by 5 divided by 5 by 2, which is nothing but equal to 2. So let's check with our options what we have in our answer. Option C is the correct answer. Hope you're clear with this. Let's move to the next question. Question number 73. Again, an integral problem with us. We have integral of log x square into x cube dx is equal to this whole thing. You have to find out the value of fx, right? Let's go with this. So we'll be using integration by parts. It's an easy question, not a big deal. So easy question, we'll be using integration by parts. Using integration by parts. So I is equal to, this is the first and this is the second function, right? So x is equal to log x square integral of x cube dx minus integral of d of log x square upon dx integral of x cube dx whole dx, right? So I think I've put on all the brackets. No bracket is left. Yes, this one. Okay. So now let's solve it further. You have this as log x square into x raised to power 4 upon 4 minus this will be equal to 2 log x upon x into this dx integral, right? So further, log x square into x raised to power 4 upon 4 minus 1 by 2. So over here, what you will get, this will cancel this one, and this x will cancel this. So you have minus log x, half will be taken outside, into x cube dx. So log x square into x raised to power 4 upon 4 minus 1 by 2. Now again, I'll be solving this whole thing using integration by parts. So have patience. Log x integral of, this has to be done really carefully because a slight mistake at any step can ruin the whole sum, right? Integral of derivative of log x upon this, integral of derivative of log x into integral of x cube dx, this whole thing, right? Okay, so further, this will be log x square, this thing, minus 1 by 2. So log x into this minus 1 by x into this. Okay, so this is equal to, actually these are two similar ones. So log x square into this minus 1 by 8 log x into x raised to power 4 minus x cube, integral will be given by x raised to power 4 by 4 plus the constant, correct? Okay, so now further, this will be equal to x raised to power 4 upon 4. I'm taking this as common outside. This was the brackets, right? So when I'll open up, this will become positive. Now I'm taking x raised to power 4 upon 4 common. You will have log x square minus log x upon 2. One thing I'll do, I'll take 30. This is equal to 4. Okay, this is, wait. There's a slight mistake in this step. Actually, this is common, and this 2 has to come, this 4. I have misplaced this 4 will come over here. Now, why is this 4? This 4 was originally this one, right? And when I found the integral of x raised to power 3, it is supposed to be x raised to power 4 upon 4. Got this thing, right? And this 1 by 2 will also be multiplied at this step. So you have over here, I'll be taking common 1 by x raised to power 4 by 32. This is what I'll be taking common. I'll have 8 over here and 4 over here. Okay, 4 log x into x raised to power 4 is already taken outside. So I'm ignoring this one. Okay, plus, so just pay attention to this, plus x raised to power 4. That's it. Question number 73. This is an integral problem. You are having log x whole raised to power 2 into x cube dx. This is equal to this expression. And here you have to find out what is the value of fx. That means you are having two functions in this integral portion. This is the first and this is the second function. Easy as that. You know, we'll be using integration by parts. So let's solve this problem by using integration by parts. Now I'll give the whole thing the name I, the whole expression. This will be integral of log x square into x cube dx. This is your first and the second function. So let's find out the integral by using integration by parts. You can write it as first function into integral of second minus integral of derivative of the first function upon derivative of the first function multiplied by integral of the second function, right? So this is whole dx again, right? So this can be a bit confusing. You have to pay attention and move very slowly in the sum because a slight mistake at any point can disturb the whole sum. Integral will be given by log x square and x cube integral will be x raised to power 4 upon 4 minus integral of derivative of log x whole square is 2 log x into 1 by x, right? And the integral of x cube will be equal to x raised to power 4 upon 4 whole dx. Now this I is equal to log x square into x raised to power 4 minus 4. This x and this x will cancel and this 2 and 4 will cancel like this. You will have half outside and this will be given by log x into x cube dx. Again, you are having two functions inside. The integral will be solving the same using the same thing, that is the integration by parts. So log x cube multiplied by x raised to power 4 upon 4 minus 1 by 2 into log x, that is the first function, into integral of second, right? This whole thing will be minus derivative or integral of derivative of first into integral of the second function whole dx. Right? So this I will be given by log x here was square into x raised to power 4 minus 4 minus this will be half into log x into x raised to power 4 upon 4 minus derivative of log x is given by, so minus minus will be plus and you will have integral of 1 by x into x raised to power 4 upon 4, right? So I is equal to log x whole square into x raised to power 4 upon 4 minus 1 by 8 into x raised to power 4 into log x, and this will cancel now. So again, you are having the integral of x raised to power 3, which will be given by plus x raised to power 4 upon 4 into 4. This is one more thing. This half will be multiplied here also, right? And the plus c because some constant will be added. So integral of log x square into x raised to power 4 minus 4 into log x into x raised to power 4 upon 8 plus x raised to power 4 upon 32 plus c. Now the whole thing I'll be taking out x raised to power 4 upon 32 common. When I'll take out this one common, I'll be left with 8 log x square over here minus 4 log x plus 1 plus c. Now let's compare it with the one we were given in the question, right? So we have this x raised to power 4 upon 32 over here into fx. So let's write it down. This whole thing was given equal to x raised to power 4 upon 32 into fx. Further was plus c. Okay, so plus c is this, correct? So that means what is your fx? This whole thing is your fx. And this is our answer. Let's check with the options what we have. This is the answer and your fx. Let's see. We have option A as our answer. right? Let's confirm. 8 log x squared minus 4 log x plus 1. Yes, we have the same thing. Okay. Hope you're clear with this. Next is question number 74. Again, an integral problem before us. So we are having integral from 0 to infinity, x raised to power 12 plus x raised to power minus 12 into log x upon x dx is equal to what? So, right, easy sum. What we'll be doing, let this whole thing be equal to some I. Now I'll put t is equal to 1 by x. Now let's find out the derivative. So dt will be given by minus 1 upon x square into dx. Right? So I can also write it as minus x into dt is equal to 1 by x dx. This can also be written as minus t upon t, minus dt upon is equal to 1 by x into dx. So we have a couple of things which we'll be using in our question. Now let's get back to our problem. We were having this thing. Let's write it down. So now I'll be writing down this whole expression in terms of t. So this is from 0 to infinity. X raised to power 12 because t was equal to 1 by x. So x raised to power 12 can be written as 1 upon t raised to power 12. That is equal to t raised to power minus 12. So this is equal to t raised to power minus 12 plus t raised to power 12. Now log x, how can we write down log x? Taking log on both sides, let's solve this one also. Taking log on both sides, I'll solve this one here. So t was equal to 1 by x. Taking log on both sides, you will have log t is equal to log 1 upon x, right? Which can be written as log t is equal to log 1 minus log x. So that means log t is equal to minus log x. This is clear, right? So what we had to write out? Log x. So this can be written as minus log t, and dx can be written as, where was dx? Let's 1 upon x dx. This can be written as minus 1 upon minus dt upon t from here. Right? I hope you are clear with whatever I have done till now. Okay. Now, let's move it further. So you can write it as, see this thing, let's write it once again. T raised to power 12, 0 to infinity, t raised to power minus 12 into log t upon t into dt. Now, let's change the limits. So can I write like this, like infinity to 0? Yes, I'll have a minus sign outside. So this is equal to t raised to power minus 12. Sorry, here was, it's okay. I can write it like this now. T raised to power 12 can be written here and t raised to power minus 12 will be written here. No problem in that. Okay. Okay. So now t raised to power 12, you know one thing, this is actually equal to x raised to power minus 12, right? So I'm going to write down the same thing. X raised to power minus 12. Similarly, t raised to power minus 12 can be written as x raised to power 12. Now log t can be written as minus log x and dt upon t. Look over here, dt upon t. This was a minus sign. dt upon t is equal to minus 1 by x into dx. Minus 1 by x into dx. Minus minus will cancel again. So you have minus infinity to 0. This whole thing was equal to I, right? X raised to power minus 12 plus x raised to power 12 into log x upon x into dx. So you see one thing, right? This is equal to I. Wait, I have done something. Yeah, okay. Question number 74. It says integral 0 to infinity x raised to power 12 plus x raised to power minus 12 log x upon x dx is equal to what? So we have another integral problem before us. Let it be I. Now pay attention. What we'll be doing? We'll be putting 1 by x is equal to t. If I'm putting 1 by x is equal to t, you can also write down x is equal to 1 by t. Let's take the derivative. So dt will be given by minus 1 by x squared dx. All right. Also, you can write down x into dt is equal to minus, okay, 1 by x into dx. Or you can also write down dt upon t minus is equal to 1 by x into dx. One more thing I would like to clarify. If I'm putting t is equal to 1 by x, let's take the log on both sides. Why I'm doing this thing right now? Because in the question when we'll be solving, we'll be using this concept. Log x we have to convert into log t. Okay, so log t will be equal to log 1 by x, which is equal to log, okay, let's write it like this, log 1 minus log x, which is log t is equal to minus log x. Hope this is clear. Okay, one more thing. If I'm saying x raised to power 12, this is actually equal to t raised to power minus 12, or x raised to power minus 12, this is equal to t raised to power 12. Why is it so? Why I'm doing it? Because we will be using this thing. Okay, now we are done with all the basic ingredients to solve the sum, and let's go towards the solution. So the question was 0 to infinity. Let's say this is I, 0 to infinity. It was x raised to power 12 plus x raised to power minus 12 log x upon x into dx, right? Now I'll be putting the whole x thing in terms of t, right? If I'm doing so, the limits will also interchange. Why? Because t was equal to 1 by x. So when x is 0, t will be infinity, and when x approaches 0, t will approach infinity, and when x will approach infinity, t will approach 0. So the limits will be interchanged, right? So this will be equal to infinity to 0. From infinity to 0, x raised to power 12 can be written as t raised to power minus 12, and minus x raised to power minus 12 can be written as t raised to power 12. Log x upon x, this can be written as log x was equal to minus log t, and dx upon dt, dx upon x, this is equal to minus dt upon t. So minus dt upon t, right? So this is equal to from infinity to 0, t raised to power 12, t raised to power minus 12, minus minus will cancel, and you will be left with log t upon t into dt, right? I hope this is clear till here. Now I'll be writing it like this. I'll be interchanging the limits. This can also be written as minus 0 to infinity, right? T raised to power, here was minus 12, no? Okay. This was minus, and here I was supposed to write down the plus. So from the, I'm changing the limits. Minus will be introduced outside. T raised to power minus 12 plus t raised to power 12 into log t upon t into dt, right? Now I'll be interchanging, I'll be converting the t into x again. You know, t raised to power minus 12, this is equal to 0 to infinity. This whole thing was equal to I. T raised to power minus 12 is given by x raised to power 12, x raised to power minus 12, and log t, you know, this is equal to minus log x, and dt upon t, this is equal to minus dx upon x. 0 to infinity, x raised to power 12, x raised to power minus 12, log x upon x into dx. Hope this is clear till here. This was originally also, this was I, so this becomes I is equal to minus of I. This was our original expression which was given to us. This gives you twice of I is equal to 0, or I is simply equal to 0. This is what you had to find out in the question. Yes, you had to find out the value of this expression, and this comes out to be 0. Okay, so we have option A as our answer. Hope you're clear. Next is question number 75. So we have lots of integral problems, one more integral problem before us. Let's write it down. You have integral minus 1 to 2 tan inverse this plus tan inverse this dx is equal to what? All right. So let's start it. Tan inverse A plus tan inverse B can be written as this is equal to there's a slight modification. Here is supposed to be 1, not minus 1 in the question. Okay, originally in the question paper, it is 1 only. So from 1 to 2 limits, in any ways, this is tan inverse. So this is tan A plus tan inverse A plus tan inverse B, which can be written as tan inverse of first, that is A, x upon x square plus 1 plus x square plus 1 upon x whole divided by, so this integral will, okay, wait, I'll rewrite. So this is integral 1 to 2. This can be written as tan inverse x upon x square plus 1 plus x square plus 1 upon x whole divided by 1 minus x into x square plus 1 into x square plus 1 upon x into dx, right? So this is tan inverse A plus B, which can be written like this. Now this is equal to 1. They will cancel out each other because this will cancel this and this will cancel this. So this whole thing will turn out to be integral limits 1 to 2 tan inverse infinity d x. You know, tan inverse infinity is given by pi by 2. Tan gives you infinity at pi by 2 dx, which can be written as pi by 2 will be taken outside 1 into dx limit 1 to 2, 1 by 2 x limits 1 to 2. So pi by 2, 2 minus 1, which is equal to pi by 2 again. So this is our answer. Simple question. We have option D as the answer to our problem. Right? Clear? Next is question number 76. We have integral problem again. So now the limits are minus pi by 2 to 2 pi sine inverse sine x dx. So now look at the limits. The whole question revolves around the limits in this question. We have limit. I'll break up the limits now. So minus pi by 2 till pi by 2 sine inverse sine x dx plus pi by 2 till 3 pi by 2 sine inverse sine x dx plus limit 3 pi by 2 to 2 pi sine inverse sine x dx, right? So now from pi by 2 to pi by 2, this can be written as sine inverse x to sine x. This can be written as x dx plus this will be pi by 2, 3 pi by 2 pi minus x into dx plus 3 pi by 2 to 2 pi minus 2 pi plus x dx, right? So x integral x squared plus 2 from minus pi by 2 to pi by 2 plus, so this can be written as pi x in, this is, that I'll take out the limits. So, integral, sorry. So pi into 1 integral is x minus x integral will be given by x squared pi 2. Limits are from pi by 2 to 3 pi by 2. Similar is the case with this one. So this will turn out to be minus 2 pi x plus x squared upon 2, 3 pi by 2 to 2 pi. Right? So now let's put the limits. So you have, when you will put this as pi by 2 whole square upon 2. So I'll take this one outside. So pi square by 4 minus pi by 2 whole square plus, let's put in the limits over this case. So you will have pi into 3 pi by 2 minus pi into pi by 2, right? And minus 3 pi by 2 whole square, minus will be plus pi by 2. This half will be outside here and half will be outside here. Pi by 2 whole square, right? So minus 2 pi, you have 2 pi minus 3 pi by 2 plus 1 by 2, 2 pi square minus 3 pi by 2 square. Now let's open it. When you will open this, 2 will cancel and you will have 0 plus. So this will be 3 pi square minus 3 pi square by 2 minus 2 pi square by 2, which will give you pi square. 3 pi square by 2 minus pi square by 2 minus 1 by 2, 9 pi square by 4 plus 1 by 2 into pi square by 4 plus minus actually minus 2 pi. 2 pi minus 3 pi by 2 will give you pi by 2 plus half. This is 4 pi square minus 9 pi square by 4. So let's write it. This will be 3 pi. Okay, 3 pi square by 2 minus this will give you pi square only. And this one will be 9 pi square upon 8 plus pi square upon 8 minus 2 will cancel, minus pi square plus 1 by 2, 4 pi square minus this will give you, this will be 16 minus 9, this will be 7. So 7 pi square by 4. These two will cancel out, right? And you will have, let's take the LCM. So, okay, this is 9 pi square by 8 plus pi square by 8 plus 7 pi square by 8, which will give you, this will be equal to question number 76. Integral limits are from minus pi by 2 to 2 pi sine inverse sine x dx is equal to what? So let this whole expression be equal to I. This can be written as, now I will break up the limits. So this can be written as integral is equal to minus pi by 2, 2 pi by 2 sine inverse sine x dx plus integral of pi by 2 to 3 pi by 2 sine inverse sine x dx plus integral of 3 pi by 2 to 2 pi sine inverse sine x dx, right? So now for this limit, integral can be written as integral of sine inverse of sine x can be written as x dx for minus pi by 2 to pi by 2 plus pi by 2 to 3 pi by 2. Sine inverse sine x can be written as pi minus x dx plus 3 pi by 2 to 2 pi. This will be minus 2 pi plus x dx. Now let's find out the integral. X integral is x square by 2 limits minus pi by 2 to pi by 2 plus pi minus x. This can be when you will find out the integral, this will be pi x minus x square by 2 pi by 2 3 pi by 2 plus minus 2 pi x plus x square by 2 3 pi by 2 to 2 pi. Now let's put in the limits. So when you will put in the limits pi by 2 minus of this thing, you will have this will evaluate to be 0. I'm just writing it down 0 plus 3 pi square by 2 minus 9 pi square by 8 minus pi square by 2 plus pi square by 8 minus 4 pi square plus 2 pi square plus 3 pi square minus 9 pi square by 8. So let's solve it further. You will have, this will be pi square plus pi square minus 17 pi square upon 8. This will be 2 pi square minus 17 pi square by 8, or this will evaluate to be minus pi square by 8. So we got our answer, minus pi square by 8. We have option B as the answer. Hope you are clear. Next question number 77. So you are given integral problem again. Limits are from 9 to x, fy by y square dy is equal to 2 root x minus 6. Here, fx is equal to what? So we'll be using the Leibniz rule over here. Question number 77. Integral 9 from 9 to x fy upon y square dy is equal to 2 root x minus 6. Here fx is given by what? So we'll be solving this problem using Leibniz rule. Differentiating both sides using Leibniz rule. What you will get? So this will be fx upon x square is equal to 2 upon root x. Right? So 2 upon this root x will be 1 upon 2 root x. Right? So fx over here will be equal to x square. 2 will cancel into 1 by root x, which will be x root x. So using this rule, this was a pretty easy question, hardly half a minute problem this was, and we have option B as the answer. Right? Next is question number 78. If the solution of dy by dx is equal to this much and y of 0 is 1 and 1 by y square is this, then you have to find out fx. So you are given dy by dx is equal to y cube cos of root x whole divided by root x into e raised to power 1 by y square. I'll take 1 e raised to power 1 by y square upon y cube this side into dy, and cos x upon root x into dx on another side. Right? Let's take the integral on both the sides. Now, this can't be solved. I'll be putting something. 1 by y square is equal to t, which gives me minus 2y y cube into dy is equal to dt. Another thing, I'll be putting root of x is equal to u. So if root of x is equal to u, then du will be equal to 1 by 2 root x into dx. We got all the things. Now we'll be just filling it in our problem. Okay. So this whole integration will become integral et dt upon minus 2. This is equal to 2 cos u into du. So this integral will evaluate to minus 1 by 2 e raised to power t, and this is equal to 2 sine u plus some constant, let it be k. Now I'll be putting the value of t. This is minus 1 by 2 e raised to power 1 by y square is equal to 2 sine root of x plus k. You are given one more thing, that y of 0 is equal to 1. That the function is at x is equal to 0 is equal to 1, which means when x is 0, y will be 1, right? So this thing will be minus 1 by 2 e raised to power 1 upon y as 1 is equal to 2 sine root of 0 plus k. right? So this is equal to, when I'm putting this as 1, this will be e raised to power 1, and this will be minus e by 2, right? I'm putting this as 1. Sorry, y was 1 over here. So minus e by 2 is equal to 2 sine 0, which is 0. So k becomes minus e by 2. This is what? Now the whole expression, this one, we had to find out the value of k. This whole expression 1 will become 1 will be minus 1 by 2 e raised to power 1 by y square is equal to 2 sine root x plus minus of e by 2. Now, taking log on both the sides with the base e. Taking log on both sides with base e. This will be log of minus 1 by 2 e raised to power 1 by y square is equal to log of this whole thing. 2 sine root x minus e by 2. So this is equal to log of minus 1 by 2 plus log of e raised to power 1 by y square is equal to, I'll not touch it, I'll keep it as such. So log minus 1 by 2 is actually log 1 minus of log minus 2. Wait, how will I write? Log of minus 2 plus 1 by y square is equal to log 2 sine root x minus e by 2. Log 1 is 0 and minus of minus log 2. This will be, I can write it like 1 by y square is equal to log of 2 sine x minus e by 2 multiplied by minus 2, because I'll be taking this one on this side. So it will be plus, so it will be multiplied. This will be, when I'll take log of minus 2 on the right hand side, it will be plus log minus 2. And if it is log plus minus 2, it will be multiplied inside the brackets, right? So 1 by y square will turn out to be log of e minus 4 sine root of x, right? So that means fx is equal to e minus 4 sine root of x, right? Over here, you were given that log e fx is equal to 1 by y square. So this can be written as log e fx, which gives you fx is equal to this term, right? Let's check with the options what we have. Option D is the answer. Hope you're clear with this. Let's move to the next question, number 79. Now, suppose that you are given two functions, f and g. They are the homogeneous functions of the same order, and you have x is equal to vy. It reduces the equation this to this form. Then f of v is equal to what? So now you know one thing you're given, dy by dx is equal to f xy upon g xy. One more thing, x is equal to vy. So if this is x is equal to vy, let's differentiate both the sides with respect to y. You have dx upon dy is equal to v plus y into dv upon dy, which gives you y into dv upon dy. Okay, yeah. Y into dv upon dy is equal to dx upon dy minus v, which gives you dv upon dy is equal to 1 by y dx upon dy minus v. So I will put this one, let's name this one as 1. From equation 1, we have this dv by dx, dv by dy. What was this? Dy by dx is equal to. So from equation 1, we have dx by dy is equal to gxy upon fxy. So this is equal to gvy comma y upon f of vy and y, right? So this becomes equal to gv1 and f of v1. Now let's put this one in this equation. So you will get dv upon dy is equal to 1 by y g v1 upon f v1 minus v. This is, see in the question, this is something of the form fv is equal to gv1 fv1 minus v, right? If you compare both of these equations, then fv will become equal to this, right? So this is our answer to the problem. Let's check. We have D as the answer. Hope you're clear with this. Then let's move to the last question, mathematical question of this paper. Here we go. We have to find out the general solution of x dy minus y dx is equal to y into dy. Let's write it down first. You were given x dy minus y dx is equal to y into dy. This can be written as minus of dx minus x dy is equal to y dy. So this is minus x dy upon y square. I'll divide both the sides by y into dy upon y square. So this will become equal to d of x upon y. This is equal to dy by y. Let's take the integral on both the sides, right? So here was minus, yes. So this will be minus x upon y is equal to natural log of y plus c, which makes y is equal to a into x raised to power y is equal to, just a minute, y is equal to a into e raised to power minus x upon y. So we have option A as the answer. Hope you're clear with this. So students, with this, we have completed all the 80 questions of this paper. Hope you were clear with this. If you have any doubts, you can rewind the video and watch them again. And please don't forget to download our app. You have the link in the description box, and also visit our website, www.examsnet.com. Right? A very best of luck. Keep shining, keep rising high, keep studying and scoring high. Bye. Best of luck.